Yeah, thank you very much. Thank you for having me at this event. I actually started working in the space of machine learning and AI around 7 years ago. I worked for a company called Bright AI. Maybe some of you know that company as well. We worked very early on generative AI for image and video data. And when we wanted to organize meetups on AI 7 years ago, it was very hard. We had to organize a lot of pizza to make maybe 20 people join the round. So it's very cool to see that now companies like dida are organizing these meetups. So many people are coming. So yeah, thank you very much for organizing this. Thank you very much for having me. I will talk to you about confidential AI today. So we can now leverage LLMs and also coding assistants with end-to-end data encryption. And I will show how this works. I can maybe already start with a problem. So when we use ChatGPT, we don't really know where our data is going, right? So I think a lot of companies are struggling with that you have a lot of LLM tools, you have coding assistants, but most of these tools are cloud-based, and when you use them, you don't know what's happening to your data. So for a lot of organizations, that's a struggle. Like, how can we use these systems? Do we have to use on-prem? And something that we see is that for a lot of use cases, on-prem isn't really an alternative. So for on-prem, you need to buy hardware. It's very hard to get the hardware. You need to pay the electricity bills. You need to deploy the models yourself. And not using AI at all is also a problem. So maybe some of you have heard about the term shadow AI. So like we had shadow IT, now there's also shadow AI, where as a company, if you don't offer these tools centrally, then your employees will start using them on their personal devices. So maybe they use ChatGPT on a personal device, and you don't really know what's happening. Thanks. So that's working now? Perfect. And yeah, as I said, the same is true also for coding assistants. I think when some of you are developing sensitive code, you don't want your IP to be exposed with cloud providers potentially, or these LLM providers. Now, I already covered that, shadow AI. Quickly about edgeless systems. So our company has been around for 5 years now. Our founder and CEO did a PhD in cybersecurity, then started working for Microsoft Research, one of the first people there to focus on confidential computing. And then Felix quit the job at Microsoft Research to say, okay, I built a company for open source infrastructure tooling that works across platforms. Not only on Microsoft Azure, but also on Google Cloud, on AWS, on StackIt, on-prem, if you have an on-prem system. And that's what we've been building over the last 5 years. Infrastructure software like a HashiCorp or Red Hat or IBM, but we do this for confidential computing. Some of the customers that we have are IBM, for instance, for electronic health records in Germany. So most of you know the E-Patientenakte. That's where our software is used for 50 million records. Now I see someone laughing here in the first row. You're probably laughing because you say the system is not secure. I read that the Chaos Computer Club did a hack or something like that. That was the front door. That was like, okay, fraud, I get access to this because I get devices from general practitioners, or I can get access to like cards that people would be using. The back-end system of the EPA is very secure. That's where confidential computing is also used. We have also a lot of other use cases, like for example with Airbus on the multi-domain combat cloud. We are enabling the StackIt cloud to have confidential computing offerings also on German cloud providers. We are working very closely with Nvidia, and we are also enabling companies across industries like SIX, the Swiss Stock Exchange, which is one of our investors. Now, what is confidential computing? So most of you know traditional data security with encryption at rest and encryption in transit. Encryption in transit, also TLS, is a standard today. Everyone should be using TLS. What is new with confidential computing is that there's also data and use protection. So there are new CPUs from Intel, from AMD, and when I say new, these CPUs have been around for a lot of years now. So it's a standard server CPU from Intel or AMD, the last 3 or 4 generations, that protect memory the memory of the CPU. So memory is encrypted. The second feature is the so-called remote attestation. Because if the cloud provider would be telling you, your data is always encrypted here, and the CPU has this built-in memory encryption, how do you prove it? So the CPU issues a certificate and says, yes, I'm a trusted execution environment. Your data is protected in this trusted execution environment on the chip. It's a very isolated environment that no other process from the infrastructure can access. And that's the mechanism. So you have remote attestation, you have runtime memory encryption. Remote attestation is very important. It's actually the killer feature of confidential computing. And what I want to show here is the infrastructure stack. So when we talk about the cloud, you have the CPU is also there, the hardware. You have employees from the infrastructure like data center employees. You have other elements like BIOS firmware, host OS hypervisor. You have cloud admins like own admins that manage an application. And then you have your workload, the guest OS, the app. The objective of confidential computing is having the CPU as a trust anchor that has these trusted execution environments where your code is like strictly isolated, no one else has access, no other process has access, and making sure that the cloud provider cannot access your data. Now there are different technologies. This is an overview from our confidential computing white paper. And there is a technology called Nitro Enclaves from AWS. And they claim that this is confidential computing. A lot of people, and also there's a confidential computing consortium, would say, well, this is not really confidential computing, because the problem with the Nitro system from AWS is they say everything here is secure, we can't access your data, but it's not possible to prove that claim. It's not possible to set up that system in your own data center. It's not possible to pen test it. Nitro enclaves don't have the built-in memory encryption. What it does is like separating your application into different levels of trust so that you can say maybe key management is handled in a different way. So partially you could say you exclude your cloud admins. But there's a lot of debate on that, and usually it's not considered confidential computing because I cannot validate the claims from the outside. As a user, I cannot validate the claims. Then what we have here at the bottom is Intel SGX. That was the first confidential computing technology from Intel. What is important to note here is, so we have this goal achieved. The CPU is the trust anchor. The CPU has the built-in memory encryption, issues certificates for remote attestation. And now what you see is the trusted computing base. The purple part on the right side is very small. But what comes with these SGX, so-called enclaves, is that they require code changes. So you need to change your application code to make it run in this secure enclave on the SGX processor. And that's why today most organizations would opt for confidential virtual machines. That means that the entire virtual machine on the cloud has these properties of runtime encryption and remote isolation. The technologies for that are called Intel TDX, Trust Domain Extensions, and AMD SEV, Secure Encrypted Virtualization. So that means now with a confidential virtual machine on the public cloud, we can use these features, runtime memory encryption and remote attestation, and we don't have to change our application code. There's also a guest OS coming with that. These technologies are available on most cloud providers. So the basis, the foundation is there. But the problem is if you just have the chip, it doesn't mean that your application is end-to-end magically confidential. And that's what we focus on at Edgeless Systems, that we build infrastructure tooling that makes it possible for you to run an application with Kubernetes, for instance, or it's all like mostly Kubernetes based, that your containers will be isolated. Yeah, there are a lot of parts around that, like TLS, key management, transparently encrypted block storage, and we are handling all of these components also. Now, what is very important for today is confidential computing is also there for GPUs now. So Nvidia has announced that with the Hopper generation, they have confidential computing also built in GPUs. So that is also possible with Blackwell, the newer generation of Nvidia GPUs. And what it has is the built-in remote attestation. So you can verify that only certain code is running on that GPU and that it's a correct H100 Nvidia GPU. And that's very important because now we can use the combination of the confidential virtual machines and the GPUs to have an AI service that is end-to-end confidential. And this is what we've built at Edgeless Systems. Nvidia wrote a blog post last year, Advancing Security for LLMs with Nvidia GPUs and Edgeless Systems. And in that blog post, they say Edgeless Systems introduced the first GenAI framework that keeps prompts encrypted at all times. And the product that we offer for that, or the solution, is called Private Mode. So Private Mode AI is like a ChatGPT. So you can just use it for inference from the cloud. You don't have to set up anything on-prem. And it will make sure that whatever you put into that system will be transparently, provably, end-to-end encrypted. So you have the end-to-end confidentiality. The service is end-to-end verifiable. So using remote attestation not only at the CPU level, but also at the GPU level. Our code is open source. So everything that Edgeless System builds is open source. We are also completely verifiable. We work with supply chain security features like reproducible builds, so it's very easy for you to also prove that that solution that you're using is based on that source code. And there's no access by us, Edgeless Systems, and there's no access by the cloud provider or the model provider. So you can use something like a ChatGPT, and your data will be provably encrypted. It's not only the open source code, it's also other organizations proving it. So there was a detailed architecture review very recently by EY. They've looked for months at the architecture, didn't find any vulnerabilities. And there was a hands-on review by TÜV IT. They did, I think, around 10, 11 person days, hardcore pen testing with full admin access, and they couldn't get any prompt data out. Now, how does private mode come? So there's an API for developers. So if you want to get started, like, you can just use an OpenAI compatible standard API, plug it into whatever system you're using, and then use the inference from private mode. What you have to install is a component that is called the private mode proxy. Because you want to encrypt your prompt locally, client-side, and for that client-side encryption, there's the private mode proxy. That is a simple Docker that you run on-prem, for instance, and then or build it into your system if you have a software. And then that proxy will handle the client-side encryption, but also the remote attestation, verifying the integrity of that system in the backend. We also have an app for users. That app has this private mode proxy built in. Now, for what we do, we serve different use cases. So we support standard LLMs like Llama 3.3, 70B. We are now upgrading also with Gemma 3. There were very good benchmarks on that. One important use case is coding assistance. In collaboration with Capgemini, we're now offering, for instance, Code Llama. For Code Stral, you would need to buy a license, but that's also possible. I think, yeah, very interesting use case, protecting IP when you use a coding assistant. And then speech to text is also a very relevant use case, for instance, for doctors. If you want to, if you have a diagnosis and you want to speak into a system and get this transferred into text, you don't want to have a GPU into every general practitioner's office, but you also don't want to just use ChatGPT and put all your patient data there. So that's a very interesting use case as well. A large project that we did together with Capgemini and IT NRW. So the problem there was IT NRW is a IT service provider in Germany's most populous state. And the question was, do we use on-prem for inference? We have like, I don't know, they had 4 GPUs or 2, and they want to serve all the public administration workers in North Rhine-Westphalia. And then they said, well, maybe that's not enough. Also, we wouldn't probably have the power to support all of North Rhine-Westphalia. At the same time, data privacy people said, we can't use the cloud, we can't put all that public, like people's information, personal information, into something like ChatGPT. So now the solution is to use private mode for inference. So Capgemini has integrated our API into their AI platform, and the result was also the security review by EY. So how this works is Capgemini has built a system where you have, like, here's the user, you have a front end, you have the core application, authentication, you have RAG also. They did all that part on-prem. But now where private mode comes in is for the heavy lifting, for the inference. So that's where private mode is used in that project. Now, often in Germany, we think, oh, privacy is something that we care so much about in Germany, and that's like a niche solution. But it's very interesting that Meta AI research recently published that they are also working on confidential AI for AI in WhatsApp. And also Apple announced last year that they have something called private cloud compute, where they're also using confidential computing, runtime encryption, remote attestation for AI workloads, because AI can't happen always on the phone. They know that the cloud will be needed for inference. And so this is where confidential computing comes in. But what is very different to the systems offered by such companies is that for private mode, for instance, it's open source. That's important. So also to verify the claims from Apple or from Meta, they will need to release their code open source so that you can validate the claims. And everything needs to be end-to-end verifiable. That's not the case for these solutions. And then the security claims for us are also validated by external parties. We are a German company. Also, maybe Edgeless Systems doesn't sound like it, but we are based in Bochum. So a hotspot for IT security. That's also where our founder did the PhD. And we have an office in Berlin as well. And then, yeah, the last point here is flexible use of models for different use cases. So, yeah, we can think of a lot of use cases. I showed coding assistance, speech to text, but there could be many others. If we look at the feature roadmap, so one thing was support for additional models. We have that covered. What is super interesting is tool calling. So agents is a hot topic right now. And when you think of agents, like someone booking your travel, having your credit card information, privacy, security gets more and more important. And so we see that enabling tool calling was one big step, and we had customer requests for that. And so now with private mode, you could also use it as a basis for inference for AI agents. What we also have integrated is caching. Some of you might be wondering, what's the performance impact of confidential computing? So if we look at the runtime memory encryption, it's around 5%. But what we have is some, so we have some performance benchmarks that we can share also with you on request. But caching was something that was very important to get this very close to the level of solutions like ChatGPT. What we also support now is native file upload. And on our roadmap is also supporting native confidential RAG. File upload was kind of the first step towards that goal. For uploading files in a confidential mode is not so easy. Also these things like caching and then keeping that all confidential still while having good performance is a tricky challenge. But yeah, confidential RAG will be part of that. And then what is also very important is multi-GPU support. That will be available with the Blackwell Nvidia generation. Right now, the one big limitation that we have is the AI model needs to fit on a single GPU. That is for confidentiality reasons because the NVLink doesn't support confidential computing. So we can't deploy like 400 billion parameter models right now. The Llama 3.3 70B that we use is quantized, but that's around the threshold, like 70B, 60B parameters. So yeah, but with Blackwell, that limitation will be resolved. So there will also be an option to have 400 million parameters model running in full confidentiality. So yeah, that's the feature roadmap. What I have here is like QR codes. I think that's a white paper on confidential AI and the private mode AI website. What's important about private mode AI website is you can also just try it out for free. So there's like the very clear, very strong documentation on everything, end-to-end encryption, remote attestation, how does it work in detail. So because we are open source, we also have very extensive docs for everything that we do. So I encourage you to also go through the docs. And if you want to get started, you can also just sign up. You get an API key and you can just try it out. Yeah, that was it. And you can also contact me on LinkedIn or email, and happy to answer your questions if we still have time.
Yeah, thank you very much, Thomas. We for sure have time for questions. So please, if there's anything. Yes, I see the first one.
I think my question is too complex, but I would like to know how it works. How does the security work?
How does the security work?
Like the encryption end-to-end over the CPU and GPU and so on.
Okay, so maybe we start with the proxy. That makes it easy. So you have the local component, the private mode proxy, that would encrypt your prompt locally. And then we have TLS to send it encrypted to the backend. And then in that backend, there's confidential computing. So there's the runtime encryption, like the trusted execution environment from that CPU. And then we have the GPU. One thing is the GPU doesn't have built-in memory encryption. So what Nvidia offers today is the remote attestation. So you can verify that the GPU is the GPU that it claims to be, that the right code is running there. But the system is a bit different with GPU. So Nvidia says it's not part of the threat model. Because it's for a hardware attacker. If we think about cloud, it's very unlikely that there's a hardware attack for like trying to get access somehow to that memory from the GPU. But that's maybe something that I can say in full transparency. So GPUs support the remote attestation, so you can verify that. And you can exclude on a logical level any access. It's very hard to get, let's say, do memory dumps on GPUs. It's not the same thing as for a CPU. Yeah, that's the broad concept. So important is you have the confidential computing environment in the cloud backend where the code is executing. And so it's end-to-end. It's encrypted in that isolated environment. and it gets sent back, and it's only decrypted with a client side. So it's really from the user in the back end, runtime encryption sent back to the user.
Okay, thank you. I will look into the details.
Yeah, look into the docs. That's probably better than my explanation. So yeah, the docs are very explicit on end-to-end encryption, on remote attestation.
Yeah, thanks for the first question. Are there more things you're interested about?
You have a limited number of models, but do you also support embedding models? Because generally in RAG applications, you embed all of your corpus, right? So this is kind of, this is almost more important to encrypt that part than the LLM queries.
I should have added that to the feature roadmap.
Okay.
Yeah, but that's an important question because we're thinking about confidential RAG and all these parts right now. For what I showed with IT and AV, it's now sufficient to have that inference part covered. So we focused initially on, okay, we do hardcore inference. Like for a customer like IT and AV, it's fine to do these other parts on-prem. So they have the RAG, embedding models, everything there. But we will work on that also, or we are working on that also.
Is it possible to generalize the concept so you just have like a confidential cloud provider where I can like deploy any kind of model and don't have to worry about confidentiality?
Yeah, it's not so easy. So we cannot make like an existing service confidential from the outside. So so we deploy the model for the customer. That's why we have private mode as a service. So it's hard. So we are pretty much doing that, what you're saying, because it's a cloud provider that has the right CPUs. They have confidential VMs. We can do that on the CPU level. They have the H100 GPUs. And then we're deploying our software framework there, including the model. So you can think of it as we are doing that because the cloud provider has the right infrastructure foundation to do that. But it's not possible for us to say, we put our framework on that cloud provider, and then you can just like plug your model into that. I think that's not how it works because the model needs to be run in these like confidential containers, and it's like an entire setup. So I think that's not the way to think about it. It's more like if a customer would say, I either want to license the framework that Edgeless Systems is using, that's also possible. Then you can have your own confidential deployment in the cloud. Or you say, I have a certain model that I would like you to run, and then we can deploy the model. But it's also an interesting question because it also works to protect your model weights against the infrastructure provider. So theoretically, you could also take our framework. If you have very sensitive model weights, then you can also deploy them with private mode, and then just deploy that yourself.
Is your encryption quantum computing safe already?
No. Confidential computing is not quantum safe. I mean, for our parts, we would just update our encryption algos, like wherever that is relevant for the software that we are building, the frameworks that I was talking about. But I think the fundamental problem is the encryption that the chips are using as of today. But they can also upgrade. I'm pretty sure that Intel, AMD, like Nvidia, they would also work on the same topics to make the mechanisms of those CPUs quantum resistant.
So it's a hardware issue, so you wouldn't see it on your side?
No, I don't see it on our side because we can easily upgrade. Like if they're state of the art and we say the state of the art today is using quantum resistant crypto and it's out there and everyone is using it, we would also integrate it into our things. I think the issue is more on the hardware side that we need upgraded hardware that supports quantum safe crypto.
Thank you. And a second question, if I may. The AWS example which you showed, is it the one where AWS offers also that you can run your models in a container, right, specific for your enterprise? Is that the showcasing you did, or is it something else?
I'm not aware of that solution. So, like what you are talking about sounds like Bedrock, like the exactly. AI foundation that AWS has. No, but so what I'm talking about is generally the Nitro platform is one thing, and then they have something called Nitro Enclaves on AWS. And that's the system that they claim to be confidential computing. And then we don't like that because it makes confidential computing a lot like a marketing term, but it's actually a fixed technology where we talk about the CPU with a built-in memory encryption remote attestation, and that's what AWS doesn't offer. But it's more like a fundamental thing in the AWS infrastructure. It's not an AI service.
Okay, thank you.
Okay, anything more? Questions? Maybe I can ask a question.
Sure.
One thing that I understood from your talk is that kind of the hardware component of the chips is kind of a very important feature for all of this thing to work. It might have happened that Nvidia has like some bug in their CPUs. I think it happened before, but does it happen did it as well happen till now for kind of these protected parts of the processor that someone found out there was a hardware bug, and what's the ability then to fix it?
Great question. So there's a lot of research on confidential computing. Some of our employees are also researching at ETH Zurich, for instance, exactly on the security of the hardware. So looking into the Intel and the AMD CPUs. And you will find articles where there were vulnerabilities in the hardware. But what is very important to note is there's a lot of research on that. You can just run it yourself, do it in research. There was always responsible disclosure, and then Intel or AMD have patched these vulnerabilities. And what is also very important to note is, in the remote attestation, you can verify that you talk into a patched system. So it's not only that Intel or AMD would upgrade their hardware and send you a patch, but you can also verify it through remote attestation, which I think, it's definitely something that proves that the system or confidential computing generally is working.
Yeah, thank you very much. Okay, then let's give another round of applause for our speaker.